Now, we said earlier there were three states of matter: solid, liquid, and gas. But each type of matter actually can be classified in threes as well. I don't know if there's something mystic about the three, but there are three types of matter. There is matter that we refer to as elements. There is matter that we refer to as compounds. And there is matter that we refer to as mixtures. And so a solid could be an element, or it could be a compound, or it could be a mixture. And so what's the difference between these three? Well, it turns out if you are an element, you are as simple as it gets, which is to say it cannot be broken down into anything simpler. So no matter what you do, you can't break it apart. So for instance, if we have something like gold, or oxygen, or silver, or mercury, no matter what we do, whether we heat it up or pass electricity through it or cool it down in very cold water or heat it up or what, I think I've just repeated myself, pour acid on it, you can't break it down into anything simpler. So that's what we call an element. Can you think of any elements? If so, say them out loud. I can't hear you, but I will know you'll be participating. Well done. So the second type of matter is a compound, and unlike an element, a compound can be broken down into two or more things. In fact, we could be a little more specific here. We could say they can be broken down into two or more elements. Okay, they can be broken down. Some things are made up of maybe, 40 or 50 different elements, a very complicated compound. But compounds can be broken down into two or more elements, and what's actually kind of neat about them is it's always in a fixed ratio. So always in a fixed ratio. And that's very important actually, because not everything in this world can be broken down into a fixed ratio. So for instance, you might think my chocolate cake should be a compound because it can be broken down into two or more things. There's no such thing as the element chocolate cake, much to our dismay in science, but it can be broken down. But unfortunately, when you break it down, the elements that comprise chocolate cake come in different ratios. So my chocolate cake's not as good as yours, I'm sure. And if you analyze it and break it down, you should see that the ratio is a little bit different between mine and yours. I think one of the really cool things about compounds is if we take something like salt, so regular old salt you might sprinkle on your French fries, and you take 100 grams of salt, what you find when you analyze it is that it's always made of 40 grams of sodium, and it's made of 60 grams of chlorine. And it doesn't really matter what salt you buy. It doesn't really matter where you buy it from, where you get it from. If you mine it from Pluto or the Earth or Mars, all salt is made exactly the same way. It is made from 60% chlorine by mass and 40% sodium from mass. So it doesn't matter the box it comes in. It doesn't matter that's advertising or marketing for you. It doesn't matter one iota. Salt is always made exactly the same way. And another example of a compound is baking soda. So if you buy baking soda, whether you buy Arm & Hammer or you buy Walmart brand, Kroger brand, it doesn't matter. It is made exactly the same way out of the elements sodium, hydrogen, carbon, and oxygen, always in a fixed ratio. So there's absolutely no difference at all between any type of baking soda you can buy from any company. The only difference in price is due to advertising dollars and markup. There, I just saved you a lot of money. The third type of matter is mixtures, and mixtures are basically a blend of two or more elements, so they can be broken down. And when you break them down, they're broken down into two or more elements. So that sort of sounds like a compound, apart from the kicker, and that is in a variable ratio. So you never know what you get, right? So just like chocolate cake. So when you break it down, it's always in a variable ratio. So examples are things like tea or beer or pizza or chocolate cake Or what's another good example of a mixture? So maybe some powdered grape soda. It's made of a slightly different ratio of sugar to fruit extract to citric acid to whatever it may be. So, for instance, I'm a big tea fan actually, so I know that the Earl Grey tea I buy is very different than, say, the disgusting, gross American tea that some people like to drink. And don't get me started about drinking iced tea. That stuff is just awful. So tea is a mixture, so it really does matter. There is better tea, there is worse tea, and hot tea is definitely better than cold tea, I hate to tell you. But because it's a mixture, it's blended differently, so one tea can be quite different from another. I guess the very last thing we should speak about is homogeneous versus heterogeneous mixtures. And so I like to think of these as sort of lumpy versus smooth. And so lumpy, please don't ever say this on an exam, by the way, would be an example of a heterogeneous mixture. And all that really means is that it's different depending on where you look. So, if this is your mixture here in a cup, maybe it's an unstirred cup of disgusting cold iced tea, and the bottom maybe is a little more sugary, and the top is maybe a little more watery. We would say that this is a heterogeneous mixture, so it's got a different composition depending on where you look. So different composition throughout, whereas a homogeneous mixture is one where it's exactly the same. So if you took that same disgusting cup of sugary iced tea and you stirred it up, and then you examined the top versus the bottom, if it was exactly the same composition, so it was equally disgusting, equally as sweet on the top as the bottom, and equally as watery and tea-like and whatever else you get out of iced tea, I suppose. And that would be an example of a homogeneous mixture. So you might remember maybe the old days of milk. Milk in the old days had cream on the top. So you had a thick layer of cream on the top and more watery milk at the bottom. So that was an example of a heterogeneous mixture. I certainly remember as kids, the milkman would bring bottles of milk around, and the birds would peck through the aluminum foil top to get at the fat-rich top layer of cream. And you were always told never to drink the milk after that because the birds had nasty, horrible diseases on their beaks, and you were probably going to get sick.